Hello and welcome back to Ganesh Institute. So we are taking up another topic from linear algebra, that is linearly independent vectors. Very important because the condition of Li works almost at every place. So what is or what are linearly independent vectors? So independent word, when I can write y is equals to 2x, so I can put any of the values in place of x, but y will always be dependent on x. X is independent here, but y is dependent on x. So whenever you can express two vectors in the form of one another in multiplication or division or addition or subtraction, then that is a linearly dependent vector condition. Okay, so what do we mean by linearly independent? When two or more vectors have or can be written as a linear combination. Okay, if they can be written in the form of linear combination, they are linearly dependent. And if they cannot be written in the form of linear combination of each other, then the condition is called linearly independent vector condition. Okay, let's see how it works. Let's say you have two column vectors. So what do you think, what is the relation between x1 and x2? You can see that x2 is the double of x1. So if you multiply 1 with 2, you'll get 2. If you multiply 2 with 2, you'll get 4. So can I write it as that x1 and x2 has a relation? That if you multiply 2 with x1, it gives you x2. So that means I can write it as x2 minus 2x1 equals 0. Because they can be written in the form of linear combination of each other. So these are linearly dependent. Okay? And if they do not give us anything. So let's say if I can write 0x1, 0x2. Then this is the condition of linearly independent. Because actually there is no equation like that. All the coefficients are 0. Right, if you consider, let's say, if you want to write them in linear combination, let's use converse, that yes, they have the combination. So let's say a1 and a2 are the coefficients of y1 and y2, and this is how they are related with each other. But can you tell me what is that condition when you apply? So this is if you distribute a1 multiply 1 is a1 plus a2 into 0. So that means a1 is 0. Here a1 into 0, that is 0. A2 into 1, a2 is 0. So that means if you have coefficient as 0, yes, this is the condition of linearly independent vectors. Getting my point? So just to recap, when you have to show that a combination is linearly independent, you need to know that there is no such combination existing, or if you want to write it in the form of linear combination, that means some relation in form of algebraic expression, then that would be only if coefficient is 0. Getting my point? So this is it.